Hello guys, in this video we will explore the difference between mean and standard deviation. This function has been written. We will discuss about this function in detail in a moment, but let us import these libraries. We need them and activate this function and let us run these two commands. First is defining an array having three values, and then we are invoking this function. Let us run this and we'll discuss about it. Look, this function is drawing three vertical lines, each representing these three values: 1, 10, 19. 1, 10, 19. And what is this red line? Red line is mean and blue line is standard deviation. Okay, so the total is 30, mean is 10, standard deviation remains this. Let us run this now. Look, here also the total is 30, but numbers are different: 10, 5, 15. And let us run this. As is expected, mean is going to be same, 10 only. But what about standard deviation? Look, it has changed. Why it has changed? See, here spread of these numbers is more. See, 1 and 19. So much of distance between these two numbers, right? Hence, the standard deviation is more over here. Whereas here, yes, there is distance between 5 and 15, but not as much as between 1 and 19. So what happens? The standard deviation of this is going to be lesser as compared to this. Next, here again, total is 30. The mean will be 10 because there are three numbers. So 30 divided by 3 will give us 10. That is fine, but what about the standard deviation? Look, all the numbers are 10. Hence, these three vertical lines are getting printed one on top of the other. So mean is 10, standard deviation is 0. There is absolutely no spread. So standard deviation is reflecting that spread is not there in this data set. Okay, so far so good. Let us understand it further. So before that, let us discuss about this function and then we will go forward. So this, and before this, let me define X like this: NP array 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 numbers are there. And here, let me comment all these lines. Okay. Let me run this function. So I defined here, now we are running here. So what it will do? Nothing. I'm printing X, it is printing X. Good. Let me remove that comment and run now. What will happen? Figure size so and so. Okay. Let me remove this comment and just see what happens. X limit means it is defining the values for X axis, and these distance has been automatically defined by matplotlib. We have not given 0, then 10, then 20, 30, 40, 50. Fine. Then now through this X sticks, we are telling that start at -1 and go till 50. And this, what does it do? Range, it will say -1, 0, 1, 2, 3 till 50. So that will get reflected in X axis. See, -1 to 50. Good. Next line. This says V lines, vertical line X 0, 5. What does it mean? See, each and every value of this X will be drawn here as vertical line. So 1 will be one vertical line, 2 will be vertical line, 3 will be vertical line. But where will vertical line start and where will it end? I'm saying it should start at 0 of y-axis and it should end at 5 of y-axis. So let us run this and see. Okay, see, 1 start at 0 and go till 5, and assuming that 5 is already there. Done. So for 10 vertical lines, 1 to 10, we have given the length of each and every vertical line. That is done. Next, what is this? V line, again vertical line, but this time for mean of x, whatever may be the mean, maybe 5.5. So here 5.5 x-axis, the very first parameter belongs to x-axis. It will bring here, and vertical line will start from 0 of y-axis and it will go till 10. Now it is till 5. So what system will do, matplotlib, it will draw a line, it will go till the value 10 of y-axis. That will result into these 10 vertical lines getting shortened to accommodate this vertical line, and just see what happens. Okay, so mean has come, it has gone till 10 and these have been shortened automatically, and the color being red for mean. Next, this for standard deviation. Now what will happen? It will calculate standard deviation, and in the x-axis it will bring that value, that, and it will start printing again vertically, at this time blue color. Okay, B stands for blue, and line style is again dashed. Let us run that. So this is standard deviation, this is mean. Okay, now just see what happens. We are not interested to see x-axis, y-axis. X-axis is fine. We are not interested in y-axis. So we are going to remove. How we can remove? By writing empty list. Y-axis gone. Then PLT show, even if you don't write, no problem. Okay, and then last is we are printing mean and standard deviation below the graph, 5.5 and standard deviation. Done. So now we know what exactly this function is doing. We have discussed each and every line. Okay, let me remove this already written on top. So this was brought here only for explaining it. Now it is already there. Good. Fine. So let us quickly explore the difference between mean and standard. We have x, right? Let us make a copy of this because we will keep changing the value of x and we will have to reinitialize x. Hence, we are making a copy of x as x1. Good. So let me delete this, or even if I run, it's no problem. Now just see what happens. Mean is 5.5, standard deviation is 2.8. Okay, now what we will do? We are adding 1 to x. NumPy allows us to add 1 to each and every element of the array using this syntax. When we say x plus 1 means we are adding 1 to each and every element, and just see what happens. Now we will run this. See, 1 has become 2, 2 has become 3, likewise 10 has become 11. Now we are invoking that function, and that function is printing vertical lines 2 to 11. And what has happened to mean? Earlier mean was 5.5, now it has changed to 6.5. but standard deviation remains same, 2.87, 2.87. Why? Because the spread remains same. Okay, let us do once more the same thing by adding 10. So what will happen? Now to 2, 10 get added. Now it is 12, and to 11, 10 get added, 21, the last number. See, all these vertical lines have shifted to represent their corresponding numbers. Mean has also shifted. Now this time mean is 16.5, whereas standard deviation remains 2.87. Why? Because, okay, the numbers have changed, but spread between them has not changed. See, 2, then 3, then 4, 1 jump here, 12, then 13, then 40, 1 jump. So there is no change in spread. There is no change in dispersion. Hence, standard deviation will remain as it is. We can do it once more to see this. Okay. Now, we kept on adding, the numbers kept on changing their places, kept on shifting right side, but standard deviation remained same. Now we will bring it back. We are saying x minus 20. So 37 will become 17. Correct? Yes. Mean has changed. Standard deviation has not changed. Same phenomenon, right? They all those numbers are together jumping forward and backward, but their spreads are unaffected. Hence, standard deviation remains same. Once more, same story. Standard deviation 2.87. Mean, of course, will change. It has come down. Now, what we will do now is we will reinstate the value of x using x1, and then this is original values. Now what we will do is we will increase the spread by multiplying. 1 will become 2, 2 will become 4, 3 will become 6. Now what is the jump? The jump is of 2. 1 has become 2, 2 has become 4. So what is the jump? 2 to 4, there is a jump of 2. Then 4 to 6, there is a jump of 2. So that will get reflected, right? Now these vertical lines are spread out, right? They are showing 2 to jump. Of course, mean will change to reflect the total divided by 10, that is 11. But this time, for the first time, standard deviation has also changed to reflect the spread. Now, earlier it was 2.87, it got doubled standard deviation. We can multiply it by 4 now. So 20, no, we should not do that. We will say 2. So 20 will become 40. We will run that. Okay. Now this standard deviation will be showing this spread. It increased 11.48. Mean, no problem. Mean will keep changing anyway. It is sensitive to the change in value. Standard deviation is sensitive to the change in spread. Okay, good. So this is a multiplication. Now what we can do now, we will okay, let us not do that. Now we will divide. By dividing, what we were doing? See, dividing by 2, 40 will become 20, correct? And 4 will become 2. So what will happen now? The spread will reduce, which means standard deviation will show lesser value. And of course, mean will change and means value will reduce now. See? No surprises so far as mean is concerned, but about standard deviation, it has reduced. Why? The spread has reduced. Okay? But look, we are discussing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is the initial number. Then we kept on adding, subtracting, multiplying, dividing. But the numbers were simple, right? But life with the data is not going to be that simple. So let us bring in random numbers. So we'll say x np random rand int, we'll say generate 1 to 21 20 numbers. Okay, and then say draw x. What will happen? See, these are the numbers. Now we may have doubt as to why we don't have 20 vertical lines, because we have 20 numbers. Simply because some of the numbers are repeating: 4 4, 7 7, 7. So if the numbers are repeating, these vertical lines will print at the same location thrice. Say if we have, say, 7 7 7, 3 or 4 sevens, so here four vertical lines will get printed. So there is overlapping. It looks like one, but there are four lines. We can't see them. So that is fine, but standard deviation is 5.2 and mean is 9.7. And standard deviation is reflecting this spread. Now, suppose we want more spread, then what we will do? We can do, okay, generate number till 41 and 20. See, one, not 41, 1 to 40 numbers will get generated. There will be 20 such numbers. And obviously, the spread is what? The minimum number is 1 and maximum number is 40. So spread is going to be more. Hence, standard deviation is going to be more. See, this time standard deviation is 12. Okay. If we increase it further, let us write here so that we can compare, right? Rather than overwriting. Now, if suppose if say 45, obviously the minimum number is 1 and the maximum number is 44. There are 20 numbers, so it will get reflected in standard deviation. It is going to be slightly more than this. See, it is 12.79 and it is 12.87. Also depends on the sort of numbers got generated, because it is random generation. Correct? Let us run it. It will certainly change. 12.87, now it is going to be different because the numbers are going to be different. And look, 12.86. So to conclude, what we have seen is the mean is sensitive to change in any value in the data set. Even if we change one number in the data set, mean is going to reflect that change. So far as standard deviation is concerned, it will not budge unless and until there is a change in the spread. It has to either shrink or it has to expand so far as spread is concerned. Unless and until that happens, standard deviation will not reflect any change that we saw earlier. And to wrap it up, we can also generate zero standard deviation. How? See, we'll say generate number between 5 and 6. What does it mean? It will not go till 6. It will be only 5. How many times? 20 times. Okay, it will generate. It has generated 20 times. It printed this vertical line 20 times. What is the standard deviation? 0. Absolutely no spread. All the numbers are same, 0. So whenever we see standard deviation as 0, we have to be 100% confident that there is one single number and that number is repeating. If we make even slight change in the value, there will be some value shown. So suppose, let us comment this and write a number like this: x is equal to, say, we will say 1 1 1. Okay, let me say 5 5 5 5 5 5 5 5, and then we'll say 5.01. Little difference, but that will be shown in the standard deviation for sure. Look, it is showing 003 because of this slight change. If there is no change at all, if it is 5, well, it will come to 0. I hope now the difference between mean and standard deviation is clear. Thank you for watching, and I will see you in the next video.